Hi, I'm Doug Seven, Senior Director at Microsoft Health Next, and welcome back to our video series on the Azure API for FHIR. In this video, we'll be looking at how to ingest data into FHIR, specifically HL7v2 and CDA data. One of the things we often hear from people is that they have healthcare data they want to use in the Azure API for FHIR. However, it's not already in FHIR format. Maybe it's HL7v2 messages, maybe it's CDA documents. Whatever the case, the need is there to convert that data from its original format or its legacy format into FHIR. The FHIR Converter is an open source tool. In many environments, you have data coming from disparate systems like EHRs, connected devices, third-party data sets. And this could be in HL7v2 data formats, this could be in CDA documents, but in a lot of cases, it's not already in FHIR. We've enabled you to convert this legacy data, HL7v2 or CDA documents, into FHIR bundles using a tool called the FHIR Converter. This is part of the ingest and enrich phase of moving data through the system. The FHIR Converter is a template-based system that takes the original data in, matches it against a predefined template that you create, and then converts that data into FHIR bundles and returns it to you. Then you can further modify that data and store it in the Azure API for FHIR. These templates are based on community input. For example, for HL7v2 data, there's an active community called 2 to FHIR that is doing the work to map HL7v2 segments and data to FHIR resources and attributes. So the FHIR Converter simply implements these standards and enables you to convert this data relatively easily from its legacy format into FHIR bundles and then ingest it into the API for FHIR. The templates that enable the transformation of HL7v2 messages or CDA documents into FHIR bundles are entirely customizable. These templates are based on work that's being done in the community, but they're a starting point for you to figure out how you want to transform your data into FHIR. The FHIR Converter is an open source project on GitHub, so you can go to github.com/Microsoft/FHIR-Converter to get access to the project, and you can clone this locally and build it with Visual Studio. As you look through the README documentation, you'll see that there's two converter engines, a handlebars engine and a liquid engine. The liquid engine is the newer engine, and that's the one we'll be focusing on in this video. You'll also notice that there's a VS Code extension for the liquid engine. You can download and install the FHIR Converter plugin for Visual Studio Code, and that will give you an editing environment for the FHIR Converter. As we continue to look at what's in the README file, you'll find information about how to use the converter and what you can do with it in the Azure API for FHIR. In this video, we'll just focus on a developer environment and what you can do with the converter, but the information for how to use the converter with the Azure API for FHIR is provided. When we're converting HL7v2 or CDA resources into FHIR bundles, we have to generate resource IDs for the FHIR resources. There is a note in here on how resource ID generation works. Within the project, there's a templates directory which includes all the templates that you need for the conversion from either HL7v2 or CDA into FHIR. Within that are a set of ID templates which manage the creation of the resource IDs based on the source templates. We also create something called a base ID, which you can use to create the reference between one resource to another. So you can maintain, for example, a patient ID as a base ID, and as you start mapping encounters or conditions, we can use that base ID to refer back to the patient. We'll see how that works in just a second. I've already cloned the project from GitHub and built the FHIR Converter locally on my machine. Now I'm going to work in Visual Studio Code to use the converter to transform some HL7v2 data into FHIR bundles. Here I have Visual Studio Code. I'm going to go ahead and press Control W to create a new workspace. And it's asking me to set the root template folder. So I'm going to go into my demo folder and into my converter folder, and I've got a folder for templates, and within that are my HL7v2 templates. So I'm going to go ahead and choose my HL7v2 templates folder as my root template folder. And then I'm prompted to select the data folder. So I'm going to go back to my demo folder and into the converter folder, and I've got a sample data folder. And in my sample data folder, I've got some HL7v2 data. So I'm going to go ahead and select that as my data folder. And then I'm prompted to save my workspace. So again, I'll go into my demo folder and into my converter folder, and I'll just call this demo as my workspace, and I'll save the workspace file. So now I've created my workspace in Visual Studio Code. And you can see that I've got my demo FHIR Converter, which was the name of my workspace. And I've got a folder for HL7v2 templates, and I've got a folder for my HL7v2 data. If I look in the HL7v2 data folder, you can see there's a number of messages here. These are all sample messages that were provided as part of the GitHub project when I cloned it. You can see a number of different things. We'll be working with this ADT message, admit discharge transfer message. Here you can see it's a typical sample, in this case for Donald Duck with a bunch of information in it. So this is a pretty typical HL7v2 ADT message that we're going to be transforming into a FHIR bundle. And we're going to do that using the templates. Now the templates work on a system where they sort of build up upon each other. If we look in the templates directory, we'll see that we have a liquid template for an ADT message transformation. And here you can take a look at what this template does. You can see it creates a FHIR resource type of bundle, which is just a collection of multiple FHIR resources. And then you can start to see what's in this bundle. So we grab some of the segments from the HL7v2 message. So here you can see an array of segments that we grab. And then we start to evaluate that to create the different resources. So you can see here we start using a resource called ID patient, and that's how we start to form the patient ID or the resource ID. But then we start to then use the patient to create a resource of patient. So if I look in these folders, this message is actually made up of multiple templates. So if I go into my resource and look at the patient template, the patient template then defines what a patient looks like here. So you can see it's a resource of type patient. And as you scroll down, you can see it includes other data types. And so we have resources, we have data types, we have code systems, all making up different resources. If you look at line 43, in the patient resource, we're going to create an element called name. And name includes things like full name, given name, things like that. So here you can see that we're going to include a data type for the extended patient name. So XPN is an HL7v2 type for extended patient name. So if I come back into my templates and I look at my data types folder and I scroll down until I find the XPN template, and I can look at that, and that just creates the name. So here we're grabbing the XPN portion of the patient ID segment, and then we're using the different values to create this name resource. If you're familiar with the FHIR patient resource, you'll recognize the different elements here of family, given, suffix, prefix, use, and so on. So this is just how the template is structuring a FHIR resource from the original HL7v2 data. So that's how it's all put together. So if I go back to just my ADT message, this is what I'm ready to convert. So in order to convert this, I'm going to start by saying this is the piece of data I want to convert. So now we want to convert this ADT message into a FHIR bundle. Now remember, we're in Visual Studio Code. This is a dev test environment. This is how I'm exploring what the template will do and how it will work. In a production environment, you would do this through API calls against templates that you've already authored. But for the authoring process, I'm going to go ahead and experiment a little bit. So I'm going to right click on this ADT message and I'm going to choose that to be my data. So my FHIR Converter select as data. So I'm going to choose that. And I'm going to choose the ADT template as my template. So I'm going to say, I'm going to choose FHIR Converter select as template. So now I've assigned which file I want to use as data and which file I want to use as template. And I can simply hit Control R to do the conversion process. So now it will take the data that I've selected and process it against the template I've selected, and we'll get the result. So now we've processed the conversions. We have the original ADT message on the left-hand side. We have the ADT liquid template we used in the middle. And then on the right-hand side is the result of this transformation. So I'm going to go ahead and give myself a little bit more space here. And we can look at the original message and we can see that this was Donald D. Duck was the patient in the HL7v2 message. As I look at the liquid template, we saw earlier how the patient resource is created and it uses the XPN template to craft the patient name fields. If I look at the result, what I've got here is a resource type of bundle. So again, a bundle of multiple FHIR resources. And the first resource in the bundle is the resource type of patient. And as I scroll down through the patient, I can see how the data was transformed. And I can get to, for example, the name node that we were looking at earlier. So I can see that Donald D. Duck was transformed into this name node. as part of the transformation process. Now, if I want to, for the purposes of experimentation during dev test, I can come in here and change data in the HL7v2 message. So for example, I'll just change it from Donald to Ronald and run the transformation again. And now I can see what's changed. So if I want to experiment with the template, so I want to maybe change data in the original message or change formatting in the template, then I can see the output of that result. So in this case, I'm using a tool for some dev test experimentation, but ultimately what I'm trying to do is define the template that will give me the result I want. The GitHub project provides you with a set of templates as a starting point, but they may not match your exact needs. So the idea here is that you can change this template to match the inputs you're providing against the output you're expecting to get what you want. The FHIR Converter is a tool you can use to transform HL7v2 data or CDA documents into FHIR bundles. In this video, we looked at how to transform an HL7v2 ADT message into a FHIR bundle. The same concepts apply whether it's a different kind of HL7v2 message or if it's a CDA message. There are templates for both HL7v2 and CDA in the GitHub project that you can use as a starting point, and then you can modify those templates to suit your own needs. Over time, we'll support more data transformations using different data sources and different templates to get you the outputs you need. In this video, you saw how you can use the FHIR Converter to transform data from a legacy format like HL7v2 or CDA documents into FHIR bundles, and then ingest them into the Azure API for FHIR. I look forward to seeing you in the next video. Thank you.